Dear students, today's topic is laser. Nowadays, laser is very popular. But why? Because of its application. Commonly, laser can be used for barcode reading. Laser printing is very much known. Laser torch is used for PowerPoint presentation. Laser is also used for radio communication in outer space. So, we have to know what is laser. Laser is an acronym. It stands for Light Amplification by Simulated Emission of Radiation. Firstly, we discuss about its property. Laser is a highly monochromatic. Now the question is, what is monochromaticity? Light can be classified into two categories. One is monochromatic and other is polychromatic. Light having only one wavelength is called monochromatic, whereas light having more than one wavelength is called a polychromatic. So, laser is a monochromatic radiation. Second, directionality. Laser proceeds along a single direction. Thirdly, laser has strong intensity. And lastly, laser is a perfectly coherent. Now my question is, what do you mean by coherent? Two sources are said to be coherent when the waves emitted from them have the same frequency and constant phase difference. Whereas the incoherent sources are the exact opposite of the coherent source. This type of source emit light with the frequency and there are random changes of phase between the photons. That is, the wave generators having a constant phase difference. Whereas incoherent sources are this type of source which have random phase change. That's why there is a basic difference between laser and the ordinary light. So, what is the differences? Laser is monochromatic, whereas ordinary light has wider range of wavelength. Secondly, we already discussed that laser beam proceeds only along a single direction. But in case of ordinary light, it vibrates along all directions. Due to this property, laser beam is more intense than ordinary light. Lastly, laser beam is coherent. On the other hand, ordinary light emits incoherent light. Now we have to know some basic concepts of transition of atoms. They are firstly absorption and emission. Emission can be categorized in two types. One is spontaneous emission and other is stimulated emission. Now my question is, what is absorption? Let us consider one atom in the lower energy state E1. It absorbs photons of incident light and gets energized and moves to the higher energy state E2. This transition process is known as absorption. Now we discuss the process how excited atoms may return to the lower energy state. There is two ways. Firstly, we discuss about spontaneous emission process. What is it? When an atom in an excited state E2 jumps to the lower energy state E1, from E2 to E1, emitting a photon at random. Then this transition is known as spontaneous emission. In this case, there is no influence of photon. Another one is stimulated emission. This plays very important role in laser action. Now we discuss how it works. When an atom in an excited state jumps to the lower energy state E1 under the influence of the photon, it emits an additional photon of same frequency of incident photon. This type of emission is known as stimulated emission. So, this is the basic transition of atoms in laser. Now we will discuss about metastable state. Look at the picture. There is 3 positions. Position 3 is very much stable. Now position 2 is totally unstable. So what about position 1? It is neither so stable nor unstable. This can be defined as metastable. So technically it is defined as metastable state is an excited state of an atom or other system with a longer lifetime than the other excited state. Metastable state has a shorter lifetime than stable ground state, but longer lifetime than excited state. Here we should learn the term population inversion. This is an artificial situation that is established by generating of large number of atoms in the higher state than that of the lower energy state. This phenomenon is known as population inversion. The process of achieving population inversion is known as pumping. In this slide, we discuss about working principle of laser. Firstly, when atoms are excited with the light of suitable wavelength, the atoms of lower energy state jumps to the excited state by absorbing incident photon. So, the atom in the state N jumps to the higher energy state H. Secondly, these atoms can remain in the excited state H for a limited time. In third stage, these excited atoms drop back by spontaneous emission and get trapped in the metastable state, that is state M. So, there exists large number of atoms in state M than that of the state of lower energy state, that is N. After that achieving population inversion, which we discussed in the previous slide, a photon obtained by spontaneous emission is made to strike an atom of the metastable state. There exists a large number of atoms in the metastable states than that in the ground state, provided the pumping light is intense enough. Finally, the stimulating and stimulated photons takes place and light amplification will start. These photons have the same frequency, same direction and the same phase as the incident photon, and that is called lasing. Now we discuss the relation between Einstein's AB coefficient. Situation is like that. N1 is the number of atoms per unit volume present in the energy state E1, and N2 is the number of atoms per unit volume present in the energy state E2. E1 is the lower energy state, E2 is the higher energy state. Nu is the frequency of radiation, and nu U function of nu is the energy density of radiation. Now the coefficient A is used when the energy density or photon is not involved, where the coefficient B is used when energy density or photon is involved. In equilibrium condition, absorption rate and emission rate must be same. Therefore, we form the equation where left hand side represents absorption rate and whereas right hand side represents emission rate. In the right hand side, First part is due to spontaneous emission, whereas second part is due to stimulated emission. Finally, we get two relations. First is B21 is equal to B12 and A21 by B21 is equal to 8 pi h mu cube by C cube. B12 stands for the transition of atom from state 1 to state 2, from the state energy state E1 to E2, and D21 or A21 represents the transition of atoms from the energy state E2 to E1. So the first relation, that is B21 is equal to B12, signifies that the probability of stimulated emission is numerically equal to the probability of the stimulated absorption. And the second relation signifies that the coefficient of stimulated emission, that is B21, is inversely proportional to the third power of the frequency of radiation. So this is the all about the laser. Thank you.